Which of these two molecules is more massive? The field goal post missing an arm, or the man who tied a bandana around his eyes? Firstly, let's dissect what the word massive actually means so that we know what we're comparing between these two compounds. Well, unsurprisingly, massiveness is the existence of a mass of a substance, and we have to measure it in different ways, particularly in grams and AMUs. This molecule, for instance, has a mass of 44.05 atomic mass units, and that's because matter has mass. The elements that compose it each have a certain amount of mass associated with them. A single hydrogen atom has 1.008 atomic mass units, a carbon atom has 12.01 AMUs, and oxygen has 16. So we've established that molecules have mass because they're composed of atoms/elements which have mass, but where are all the elements in these two molecules? Well, it might be helpful to write this molecule from earlier in a different way, in the same way as our two molecules of interest, as a bond line structure. So the question is, what Lewis structures correspond to each of these two molecules? Well, let's dissect them. All of the ends and bends are carbons, and based upon that, it's clear that each of these molecules have 5 carbons. By nature of its properties, each atom of carbon will form exactly 4 bonds, but it's clear that from looking at this diagram, these carbons don't appear to have 4 bonds. Well, for this carbon right here, we do see all 4 of the bonds, but for the others, we don't see all of them. Specifically, we only see the bonds between carbon and carbon. This carbon right here has 4 bonds like the rest, but we only see one of them. And hydrogens are going to make up the difference. So if this carbon has 4 total bonds and we see one of them, one carbon to carbon bond, it has 3 hydrogens attached to it. We use this equation right here to do the same, and for all the other carbons, the number of hydrogens attached to each carbon is the number of bonds it has, 4, minus the number of carbon to carbon bonds we see. And I want to emphasize, we do this calculation for each individual carbon in these molecules to reveal all of the hydrogens. Now, since we have all the atoms for each element of our molecule, we can construct our molecular formulas, C5H12 and C5H9. So comparing the molecular formulas, it looks very much like A is going to be the correct answer, but let's just make sure. Unsurprisingly, because there's an equal number of carbon per molecule, 5 each, the deciding factor is hydrogen. So whichever has more hydrogen has more mass overall. Therefore, A is the correct answer. The molecule on the left is more massive. But how do we know for sure when we use grams and when we use AMUs? Check out the video on your screen to find out.